Now let's look at a little more complex decision tree model. The same problem like before, the Thompson number. We have three possible alternatives: big plant, small plant, or do nothing. And the market condition could be favorable or unfavorable, right? Now, before making that decision, suppose if John Thompson wants to hire a market research consultant and do a market study. Yeah? And the market study is going to cost him $10,000, right? Now, the market study will then predict whether the future condition is going to be favorable or not. Okay, of course, this is only a prediction. This is not going to be certainty. So based on this consultancy prediction, then Thompson will have to make a decision whether to build a big plant, a small plant, or do nothing. But because of this additional information, so the probabilities are going to be different. Now, our prior probability was 50-50, right? Favorable 50%, unfavorable 50%. Now, if the market research or market survey predicts favorable market, okay, then we are assuming that the probabilities, the survey predicts favorable market, then the probability that the market will actually turn out to be favorable is 78%, and so 22% will turn out to be unfavorable. If the survey predicts unfavorable market, then favorable market probability is only 27% and 73% is going to be unfavorable. So these are the conditions. $10,000 is going to be the cost. And so now Thompson has another decision now before he can decide whether to build what kind of plant. He has to decide whether to hire this consulting company to do the market survey. So let's head back to the decision tree. Okay, and I'm going to open the first decision tree that we made, so we can build on this. So I'm going to save this with a different name, market survey maybe. Okay, so my original decision tree is not altered. Okay, so now I want to add a decision node, right? And I'll call that decision node market survey. Right? Okay. And I'm going to add a chance node. Okay, so that will be, okay, do market survey or conduct survey. All right. And the payoff is minus 10,000. Okay, if you conduct survey, it's going to cost you 10,000. And if you don't conduct a survey, right, then there is no chance here. You're not, there is no, what kind of prediction there is going to be. There is no market survey, so you go straight to a decision node, right? And that decision node is already here, plant decision. So what I'm going to do is I'm going to copy that, right? And I'm going to paste it to this. All right. Okay. So now I have conduct survey and no survey. If it is no survey, and let's see, I'll go ahead and, okay, no survey. Okay. So no survey means there is no change. It's exactly same as before. Now, if you conduct a survey, then you're going to have, you need the same decision to make now after conducting the survey. Okay, so I'm going to paste the tree that I copied here. All right. So now I have an edge coming out of conduct survey. So click conduct survey, call it predict favorable, right? All right. So now I need one more. Again, paste here. So that will be, okay, so let's click here. Oh, I'll put edge 1 as predict favorable and edge 2 as predict unfavorable. And the problem states that if you look at the problem states that there is a 45% chance that the survey will result in favorable market. So the 45% chance that the survey will predict that there will be a favorable market, and 55% will be unfavorable. So predict favorable probability is 0.45. Predict unfavorable probability is 0.55. Okay. So now we have to alter the probabilities like here. If the survey predicts favorable, it is 78-22. So here it's going to be 78 and 22 for each of the 3 chance nodes. 78, 22, and do nothing. Well, actually do nothing is terminal node, so I'll just do 78, 22. Now if the market survey predicts unfavorable, then the probabilities are 27 and 73. So it should be 0.27 and 0.73. 0.27, 0.73, and 0.27, 0.73. All right, so now we have completed. Okay, we don't need this anymore, so I'm going to cut this out, get it out of the way. All right, so now we have Thomson number. Okay, no survey. Okay, so the decision has an expected value of 40,000. All right. Now, if you conduct a survey, that's going to cost you $10,000. Okay, so you see the net outcome for each terminal node. The net outcome is shown here. Okay, net of that $10,000. So here you get the expected value based on the revised probabilities, and then the maximum of these 3 decisions is here. So this is 116,400, and then here you have and in this decision the monetary value is 12,400, then that times probability 0.45, 12,400 times probability 0.55 gives you expected monetary value of 59,200. Okay, minus $10,000 market survey cost. So 49,200 is the value here. 40,000 is the value over there. So the worth of market survey, the value of market survey is the difference between this node and that node. So the value here is 40,000, the value here is 59,200. So market survey has increased the value by 19,200. So the value of sample information, the sample information being the market survey, is 19,200, of which you're paying the market survey $10,000. Okay, the market survey itself is worth 19,200. You're paying him 10,000, so you are ahead by 9,200.